Bismillahirrahmanirrahim. Okay, we have to see how to differentiate the functions which are defined implicitly. Okay, we have been differentiating so far the expressions or the functions which were in the form. Let me tell you, where you had the linear functions, the quadratic functions, cubic functions, logarithmic functions. Okay, you had always either y the subject of those equations, like if you had a quadratic equation like this, okay, or if you had maybe a trigonometric equation like this, y is equal to sine x, blah blah blah, okay, or ln x or e raised to power x. So these were they're called the explicit functions. Okay, when you don't have y the subject, if you look at this situation here, look at this example here, this is x cube plus y cube, that is equal to 4xy. The equations like these equations are basically showing the implicit functions. Okay, these are showing the implicit functions. So we have to see how to differentiate, how to find dy by dx in such cases. Okay, um, one of these implicit functions that you people are aware of is that equation of a circle that has been included in the syllabus in P1. It is like x square plus 2x plus y square minus 4y equal to, like, you know, you have a number over here, okay, like this. So this is an implicit function, the equation of a circle. You can see that y is not the subject over here. So then when you have such equations, such situations, then how to differentiate such equations with respect to x and find that dy by dx, or maybe the second derivative, and then determine the turning points or the rates of change kind of things. Okay, so for this purpose, I will tell you some points over here. You see them, okay? And then we shall discuss those. Okay, now suppose you have x square plus y square that is equal to 5. I'll take a very easy, simple example over here to explain to you that how do we differentiate such uh, equations or functions. So we are going to differentiate this with respect to x. So the derivative of x square is 2x. The derivative of this y square, I'm not going to write anything over here. I'll suppose that this y square is u. Okay. So then this will be du by dx, and that is going to be equal to 0. Now, this is your u equal to y square. We have substituted y square as u. We can find du by dy from here, which will be 2y. Now, we were looking for du by dx, okay? You can use the chain rule over here, du by uh, this, and then this is this is dx, and you write dy here, and you write dy over here. So du by dx is going to be 2y, and then you have dy by dx with this. Okay, so this becomes 2x plus 2y dy by dx, that is equal to 0. So that is how you will be getting the derivative from this x square plus y square equal to 5, which is basically an implicit function. So when you are doing in a flow, you will not be required to show all these steps. You just remember that the way you differentiate it is x squared. The derivative of x squared is 2x. Similarly, you will differentiate this y square, but you will write an extra dy by dx with that. Just remember this. If you want to show the reason, which is not required when you are solving a question, you can show it like this. Otherwise, the derivative for this x square plus y square equal to 5 is going to be like this. Now, suppose you have, let me give you one more example. Now, suppose you have, let's say, um, let's say you have uh, uh, 3x square minus 5y square plus 2x plus 6y equal to 5. Okay, so the derivative of 3x square is going to be 6x. The derivative of minus y square will be minus 10y, and you will just write a dy by dx with this. The derivative of 2x will be 2, and the derivative of 6y is going to be 6, and then you will write a dy by dx, and never forget to differentiate this right hand side, which is going to be 0. Suppose you have, let's say you have sine x plus sine y plus e raised to power 2x minus e raised to power 2y, that is equal to 3. So the derivative of sine x will be cos x. The derivative of sine y will be cos y. And when you differentiate the angle, which is y, with that will be 1 dy by dx. Suppose you have this is e raised to power 2x, so this is going to be 2 e raised to power 2x, and this one will be 2 e raised to power 2y, and then you will write a dy by dx, and then you will put that is equal to 0. Similarly, if you have, for instance, um, moving towards the more complicated situations. Now, suppose you have, uh, you typically have in your exams a question like, suppose there is 3x squared plus uh, 4x squared y squared plus 2y cubed, that is equal to 3. So 3x squared's derivative is going to be 6x. Now you see this is a product over here, 4x squared y squared. You can write it as 4 into x squared and then y squared, and then you can differentiate. Look at this. It's going to be 4 into the derivative of x squared is going to be 2x, and then y squared would come as it is, plus x squared as it is, and then the derivative of y squared would be 2y dy by dx. So you have to apply that product rule into it. The 6x plus 4 into, this is 2x y squared plus x squared times 2y dy by dx. And then you have plus 6y squared. This is dy by dx, that is equal to 0. So now you have to rote memorize or just remember that whenever you differentiate a term in y, you differentiate it exactly the way you're differentiating the term in x, but you will write an extra dy by dx. Okay, I have given you the reason for that because we were using the chain rule to get to this derivative of this y with respect to x. Now, once you're done with this, then uh, your favorite algebra comes in action here. You have to simplify this, you have to take common, and then you have to find, like, suppose if you have to find the value of dy by dx. So see, this will be 6x plus 8xy squared plus 8x squared y dy by dx plus 6y squared dy by dx. Okay, I'll move this to the other side of the equation and I'll take dy by dx common from here. So we have 8x squared y plus 6y squared dy by dx. You can write it here, and that is equal to, can write it as minus 6x plus 8x y squared. Okay, and then finally you have this, let me cover this, and then here is your dy by dx. That is, if you want to take a common from this right hand side, I think there's minus 2x is common here. This is 3 plus 4y squared. You have a common from this. There is 2y is common from here. This is 2y into 4x square plus 3y. And then you can simplify this with this. So that is how you will be getting the dy by dx while differentiating an implicit function. Okay? So
Yes, sir.
now you have to go back to this exercise and you will try these questions. First of all, from here, you have to differentiate them. Okay? You try them and then I'll tell you how to do these. Okay, just see how these were to be differentiated. This is basically, this a part is d by dx of y raised to power 5. So this is 5y raised to power 4 dy by dx. Okay, look at the b part. This is going to be 3x squared. Now these are not equations, these are just the expressions. Okay, so this is 3x squared plus 4y, and then you have dy by dx. Then you have the c part, that will be 5x squared's derivative is 10x, then plus ln y. That is, first of all, it will be 1 over y, and then the derivative of y would be dy by dx. That is how you do these first three parts. If you go into the parts d, e, f, there you see like the part d. It says 2 plus sine y. The derivative of 2 is 0, and sine y's derivative will be cos y times this dy by dx. You can write it like this, cos y dy by dx. Look at this e part. You have 6x squared y cube. So this is a product here, 6x squared y cube. So this will be keeping it like 6 into the derivative of x squared is 2x, and you have y cube as it is, plus this x squared, and then the derivative of y cube is 3y squared dy by dx. And then you can write it as 12xy cube plus 18x squared y squared dy by dx. That is how you do this e part. Now look at this f.
Sir, could you please repeat this E part?
Look at this e part. It is clearly product. There is this x squared, and there is this y cube. Okay, I'm keeping this 6 out of it. So the 6, and then the derivative of x squared is 2x. Okay, and y cube remains as it is. This is 2x y cube, and then plus next time x square remains as it is, and the derivative of y cube is going to be 3y squared, and you write times dy by dx with that. You can look at this f part. It is y squared plus xy. So when you differentiate this, the derivative of y squared is going to be 2y dy by dx. And then again, there's a product, this xy. Do see, be careful whenever there are products or the quotients. Okay, so it's xy. When I differentiate x, it is 1, and you have y as it is, plus x times the derivative of y is 1 times dy by dx. If you want, you can take dy by dx common from these two terms here. Okay, so you have 2y plus x, there is dy by dx, and plus y. That is the f part's final expression. Okay? If I take you to the, I mean, these parts which are coming after the f part, you see that you have, let's look at this parts g and, okay, this part g. So in this g part, you have x cube minus 7xy plus y cube. So the derivative of x cube is going to be 3x squared. You keep it this minus 7 out, and then you apply that u dot v. The derivative of x is 1 times this y as it is, plus x as it is, and the derivative of y is simply 1 times dy by dx. And then you have plus 3y squared, and then you have dy by dx. So just remember that whenever you're going to differentiate this y, the term in y, you have to write that dy by dx with that, okay? So this becomes 3x squared minus 7y minus 7x dy by dx plus 3y squared dy by dx. And this becomes finally 3x squared minus 7y, and you take minus dy by dx common from here. This is 7x minus 3y squared, and you have this dy by dx. Okay, man? See how I'll be differentiating the H part. H part. Okay. Now this says x sine y plus y cos x. Both are products. So we apply this product rule on x sine y. So this is going to be x derivative is 1 times sine y plus x as it is. Sine y's derivative is going to be first of all cos y and then times dy by dx. Then y cos x. Y's derivative is dy by dx. Cos x comes as it is. Then plus y times cos x derivative is minus sine x. Okay, we simplify this a bit. We have sine y and minus y sine x, and I can take dy by dx common from these two. So I have x cos y plus cos x times dy by dx. So here we are. Okay. Um, should I do these I, J, K, L as well, or you can try them? Mhm.
Sir, I'll try them first and then I'll let you know.
Okay, okay, okay. Okay, one last part. There is the L part. Okay, so we have L part says it is 2x e raised to power cos y. Okay, so 2x, I'm keeping it as 2 into x derivative is 1 and e raised to power cos y remains as it is plus x as it is. Now, e raised to cos x derivative is e raised to power cos y.
Cos
Uh,
y
The power was
dy
cos y.
by
No, 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 no. You will first write minus sine y, and then you will write dy by dx. Because the power is cos y. The cos y derivative is minus sine y and then dy by dx. So this is going to be, I am going to, okay, I'm not going to take anything common from here. This is 2 e raised to power cos y minus x sine y e raised to power cos y dy by dx. So this was it from the very first level of this implicit differentiation. Inshallah, tomorrow I'll give you some, maybe let me show you what we will be doing tomorrow. Yeah, we will be finding dy by dx from here. Okay? Okay.